Hello, welcome to another session of completing the square. This applies for quadratics. So exactly what is meant by completing the square? What exactly is completing the square? So completing the square is the process of taking any quadratic, that is ax squared plus bx plus c, and transforming it into this form, that is a open bracket x plus h all to the squared plus k. A, h, and k are constants, meaning numerical values. So what is an example of this? Let's look at a quadratic here. X squared minus 4x minus 1. Is this a quadratic? Simple answer is yes. Why did I say that? Well, a is equal to 1, b is equal to minus 4, and c is equal to minus 1. So this qualifies as a quadratic. Alright, now this process allows us to transform this quadratic into a complete square form. Alright, so after we complete the square of x squared minus 4x minus 1, we get x minus 2 all to the squared minus 5. Okay, so here it is. We already have this here done for us already. Alright, so let's expand x minus 2 all to the squared minus 5. To expand this piece here, you actually get back x squared minus 4x minus 1. Alright, but exactly what is this process all about? Alright, what exactly are we doing here? What does this look like on a graph? What is the visual behind this? To understand this, we need to look at this on a graph sheet. Alright, to get an idea, a sense as to what this looks like. Alright, so the graph of x minus 2 all to the squared minus 5. What does this look like on a graph? Visually, this is what it looks like. Alright, you see the graph here is centered at 2 and is further down at negative 5. Alright, you see here negative 5. Alright, so these are the two key points of this graph. Alright, so exactly what is meant by this? Well, to understand this, you need to understand first that x minus 2 all to the squared forms a perfect square. If we were to remove the negative 5, well, let's see what happens. Alright, so after removing the negative 5, alright, just have x minus 2 all to the squared. So x minus 2 represents a perfect square here. See that? This is what is meant by the perfect square. Alright, so the graph here is actually centered around one point. That is at x equal to 2, at here. Alright, so only one x value exists at this point. Alright, and this is what we refer to as the complete square. This is what we refer to as a perfect square. Alright, by including the negative 5, we actually bring the graph down 5 units downwards. So let's see what happens when you include the negative. So with the inclusion of the negative 5, we actually see that we actually bring the graph down by 5 units. 5 units downwards, or negative 5 units. Alright, so we start off with the graph centered at x equal to 2, and now we just bring this graph physically down by 5 units downwards. See? To negative 5. Alright, and this is the effect of completing the square. Completing the square allows us to take any quadratic and bring it back into the form a open bracket x plus h all to the squared plus k. In this case, our a is 1, our h is minus 2, and our k is minus 5. Alright, so completing square allows us to transform the quadratic back into this form. Alright, visually it looks like this. Alright, like any quadratic graph. Alright, the idea here is to express the quadratic in terms of a perfect square plus additional constant which we call k. Alright, so this is the effect of computing the square. Alright, now you may ask questions as to, well, how do we go about computing the square? Alright, now a million and one methods exist. There is no one specific method. Alright, so many ways exist as to computing the square. There is no one single method. Alright, thank you. I hope you learned something today as to the relevance and the significance of computing the square, a deeper understanding of what is meant by computing the square. Thanks.